All right, hey everyone. So we're going to be playing around with this cool contraption called the Van der Graaf generator. And when I turn it on, what's going to happen is it's going to become charged. That that top metal sphere becomes charged, and you can see the electric charge is bouncing or coming off of it and like getting me and getting the base of it there. And so we're going to use it to charge different objects up throughout the unit. And maybe if you're lucky enough when you're in school one day, you can come get shocked by it too.
All right, so for this next demonstration, we have a metal ball. It is a conductor. And what we're going to do is we're going to put a bunch of charges from the Van der Graaf generator onto the X of this metal ball, which is a conductor. We're going to put all the charges right there. Then what we're going to do is we're going to also put the same kind of charge on this thing here. This is called a pith ball. It's also a conductor. And what we're going to see is we're going to see if these things attract or repel. So if you look now, nothing happens, right? Maybe we have a little
Nothing
bit.
much, a little bit.
This is our second take. So.
Yeah.
And what we're going to see is we're going to see what happens with the X, if it attracts or repels or anything. And then we're also going to see what happens on the other side where we didn't put the charge. All right. Okay. So prepare to be shocked. All right, kill it. Yeah, that's good. All right, so I'm going to bring it a little bit higher, I think. There you go. Bring it close, and I can see it repel. So it repels from the X, so those must be the same charges. Now I'm going to spin this around where I didn't put the charges. Let's see what happens. And it repels as well. So even though I put the charges only on the X right there, can't point at it, I'm going to get shocked, the charges have now moved to the other side. And in fact, they've moved to the top. See how it still repels? They've moved to the bottom. They've moved everywhere. They've spread out across this whole conductor. And we can see that because the pith ball, the little pink thing, repels every single side of this charged metal ball.
Okay, so we just looked at two conductors, the pith ball and the metal sphere, and now we're going to look at two insulators, two balloons, right? And what we've done is same thing as the metal sphere. We put X's on these, and we've put charge at those X's. So we put some charge on that spot, and put some charge at this spot. And what we're going to do is we're going to try to bring those X's together to see if they touch. Our goal is to see, did the charges spread out? We know there's charges there, but did they spread out on the green balloon? So let's watch the green balloon and see if we bring them close, if they repel, because they're like charges. And you can see that the two X's I cannot get them to touch each other. It either spins away or it just pushes away. They won't touch each other. The question is, did the charges spread out to the side opposite of the X? So now I'm going to take the side that's opposite of the X and I'm going to bring it close to the purple guy, and we can see no problem, right? They touch, they're not repelling. And so again, what that means is that the charges stayed at the point of the X. So if I try and bring them close, we can easily see that it spins away, it repels. So clearly there's charges on these two X's, but when I spin it around, the opposite side of the X, they're comfortable coming close to each other, they're not repelling. So we can conclude that with the insulators, the charges stayed at the X and didn't spread out, opposite of what we found for the conductors.
All right, so this is our Van der Graaf generator. Remember what it does is it's going to put extra electrons on this metal conducting sphere at the top here. Now we could actually change to a different belt that's in here, then it's hard to see. And so we could actually steal electrons away, but for this demonstration, we're going to be putting extra electrons here. So what's going to happen is, when I turn this on, the machine is going to add more and more and more and more and more electrons here. This is a conductor, so those electrons can move around. And we have this rabbit fur that's sitting on the top. So the rabbit fur is just fuzzy, it's got the hair, all the little, sheds like crazy. And so what I want you to predict first, before we do it, is what's going to happen to this fur. Because this fur is going to have a bunch of extra electrons. So there's going to be extra electrons here, extra, so many billion extra electrons. What are they going to do? So make a prediction first. And then now we're going to turn it on and see what happens.
Whoa, cool.
All right, so what's happening here? It still has those extra electrons on there. So those excess electrons are going to repel each other. And when they repel each other, there's a force there, and that can actually push the rabbit fur away from the sphere. So those electrons can get further away from each other. And even the individual hairs on there, if we put these are the hairs, extra electrons on all these, they're going to push away from each other. So we see all the hairs standing up everywhere. All right, so we got our magnetic generator with our rabbit fur on there, and remember, we're going to put extra electrons on here, and those electrons are going to want to get away from one another. So this is some of the hair. They're going to want to spread out and get away from each other, so we're going to see the hair stand up. And that means there's a lot of extra electrons on there in this case. But you'll see I have a magic wand here. And on this side, the hair isn't standing up anymore. And that means there aren't any extra electrons, or not as many at least. And now if I move this away, we get some extra electrons, and it's kind of a cool little thing here. And you can even see it or maybe hear it shock as they're coming off there. There you go. So there's all those extra electrons are jumping to this wire here. Yeah, see if you can get close enough. Trying the iPad. You can see those are extra electrons. Jump, 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 jump.
Yeah.
Jump, 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 jump. So what's going on there? This is a really, it's like you have the Force, right?
Yeah.
The Jedi. So what's going on there? So we know that extra electrons are going into this wire here. We can see them when it sparks, and then we also see the hair go down. So you'll notice that this wire here, this phenomenon is called grounding. This is a wire. There is metal all inside there where it's a conductor, so the electrons can go through that. And this wire is connected all the way back to the shower, okay? Well, this shower is metal, and that's connected to metal pipes in the ceiling, that's connected to the drains and all the other pipes in the building, and connected to the sewer and all this kind of stuff. So essentially what's happening is this is neutral, and that is really, really negative in this case. So the electrons want to get away from all the other excess electrons. And so they can jump to here, and this is a conductor so that they can flow through here. And there is so much space that way that they can just keep going and going and going. So technically, maybe we're adding a bunch of electrons to the building, but the building is ginormous. All the pipes connected to it are so big it doesn't matter. An analogy I often use, if you go out to the pond, and you take a can of Coke or something, and you dump it in the pond, okay, you put more liquid in the pond, but the level of the pond isn't going to go up at all. So what we say is the building, this is the ground. We call it the ground, and it has approximately an infinite amount of atoms. And so if you add some extra electrons to it, it doesn't really matter. And so we still say, even though I added a bunch of electrons to this, it's neutral, because essentially it is, because I'm not going to get shocked, nothing's going to happen. So when I ground this, the extra electrons go from the charged object into the ground, and then everything ends up neutral in the end, because the ground is so big, adding some extra electrons does not matter.
All right, folks, let's check in and see what happens when we ground a conductor, or what that looks like to ground a conductor. So I've got my conductive metal sphere here, and it's currently neutral. It's currently grounded and neutral, and we can see that it's neutral because when I bring it close to the pith ball, there's no attraction, no repulsion, no force whatsoever. So let's charge it up. Let's make it negative. Get my Van de Graaff generator going. I'm going to charge it up at the X, put the extra electrons there. You heard them go on there. Let me turn this off. Okay. And now let's verify it's charged by bringing it close to my pith ball, right? And so we'll see that there's a force, right? We can see that there's a force there, and that's from the X side. And even if I rotate this around so the X is away, we still see that it's repelling. Remember, because with conductors, charges can spread out, and so the extra electrons spread out. Now, I'm going to take my grounding rod and touch it to the side opposite of the X, so like this. Okay, so I touched it there. Now let's see what happens when I bring the X close to the pith ball. No longer any force, right? So what that must mean is that the extra electrons on the entire sphere are gone. Just by grounding it anywhere on here. So for a conductor, because of the fact that conductors allow electrons to flow throughout them, if you ground at any point, it's going to make the entire conductor neutral. Okay, so now let's talk about grounding a insulator. So we got a rubber balloon, which is an insulator. It's made out of rubber, which is an insulator, and it's currently neutral. Come take a look. I'm going to hold it close to the pith ball, and we'll see that there's no forces or anything like that on the side with the X, or even the back of the balloon. There's no forces going on there, right? Now, I'm going to charge that spot of our insulator, the balloon, and I can do that. We can charge things up by rubbing them against other things. For example, I've got some rabbit's fur here, and when I rub this X, it's going to charge it up like so. Now, let's verify that it's charged. We'll bring it close to the pith ball, and we can see, oh, yeah, there's definitely some charge there. It definitely attracted. I'm going to just ground the pith ball, make sure it's neutral, because it's supposed to be neutral. I can do that by grabbing it with my hand. And we're going to try and ground the balloon. So I can touch it with my hand on the back. I could use the, but we're going to try grounding it on the opposite side of the X, right? Just like we did with our conductor. So I touch it with my hand. I can touch it with the grounding stick, right? So there's lots of ways to try and ground it. Now the question is, did that ground the entire balloon? We saw that that grounded the entire conducting sphere, but did it ground the entire balloon? Let's test it out. Let's see if we bring it close to the pith ball, what happens. Nope, you can see it did not ground the balloon. So the only way you can ground an insulator is to ground the spots, all the spots where the extra electrons or extra charge are. So if I go and I put my hand here, that's going to ground it for the most part, because to be totally honest with you, it's really hard to find every single extra electron there. And so that's the best way of trying to ground it, is to do something like that. We can test it.
Ground the pith ball.
And see. Yep, did pretty well. Cool.
All right, so this unit we've been talking about charge, and you learned in chemistry about charge. And I'm sure you learned opposites attract and likes repel. And so like in an atom, an electron and a proton are going to attract each other. Two electrons are going to repel each other. And you learned in chemistry that a neutron and electron are just going to ignore each other, or a neutron and a proton are going to ignore each other. And that's still true. In physics, we aren't dealing with individual atoms, we're dealing with objects. So the thing to remember when I show you these demos is that these objects have protons and electrons in them at the same time. And that's going to be the key to understanding it, that an object itself, if it's negative, isn't all just electrons, but it has electrons and protons in it, and vice versa for a positively charged object. So I'm going to take our friend the balloon and our rabbit fur, and I'm going to get this all charged up, and then I have a wall here, right? Neutral, didn't shock me, whatever. And I have we'll say this is a negatively charged balloon. So I have a bunch of extra electrons on here. So neutral object, negatively charged object. You probably know what's going to happen because you've done this before. But negative and a neutral, from chemistry, that shouldn't work. But they attract. So here we're seeing a negatively charged object and a neutral object attract each other. I'm not going to go into the full explanation, but the key is that there's not just a bunch of neutrons in there. There's electrons there and protons. So let's try it with something else. Let's try it with this little pith ball here. So this pith ball is neutral. So neutral object, negative object. And we see they attract. What's going on here? One thing also, the pop can. So put pop can here, it's neutral, didn't shock me or anything. And I'm going to bring the balloon close to it. Woo! And what happens? They attract. Got some pieces of paper here, just some trash. Bunch of neutral pieces of paper, bring this close to it. And they attract as well. Oh, it stands up. Now I want to change one thing here, because you may be thinking that the negatives on here are attracting all these neutral objects, which is true. So what I'm going to change is I'm going to change this from negatives. I'm going to steal the negatives off here, and I'm going to rub it with a piece of paper. And now I've stolen all the extra negatives and stolen extra. So now this is positive. So let's see if it still works. So we're missing electrons in here, so we have extra positives on there. See what happens. Whoa! So now I have a positively charged object attracts a neutral. Let's see if it works with the paper. Oh, there it goes. Whoa. So it's not a rule that the negative object attracts a neutral, or just a negative object. If a negative attracts a neutral, and a positive attracts a neutral. Okay? So we're going to learn about why that is, but remember the key is that this neutral object is not neutrons. It's protons and electrons and neutrons.